You are currently looking at the rig, as we call it, the optical setup that I use for a lot of my experiments. Now, essentially, this is Raman. Raman is a type of spectroscopy. What happens is you shine a laser onto your sample. That excites all of the bonds in your sample. I mean, I'm doing this, but this is kind of exactly what happens. All of the bonds shake and they also wag and breathe like this. And the effect of that is it takes some of the energy from the laser and then emits that as different colors of light, and it scatters in a kind of all-round direction. What we do here, so you have your lasers in the back and they come in through here, and then you put your sample down there. And then all of this scattered light comes back up through here, and you collect it as a spectrum. And what that tells you is exactly which bonds have been wiggling and vibrating. That's really useful when you're trying to look at chemistry, because chemistry is breaking and making bonds. So breaking and making bonds, and I can tell which bonds are in it. Great, cool, I can tell what chemistry is going on. So that's what you're looking at right now. The way that we've done it here is in quite a kind of fancy pants way. So you can have multiple lasers, so you've got different colors of light going in. And this image here is actually my sample. So I do something called surface enhanced Raman spectroscopy, which is, I just explained Raman, I just sort of explained spectroscopy. So surface enhancement is if you put the things which are shaking and wiggling and breaking next to something like gold. It turns out that when you shine the laser on, the laser has way more of an effect than before. So this way more of an effect is due to this sample. Now, these things here on the screen, they're actually gold nanoparticles, and they're around 80 nanometers big. But they look way bigger. Here it looks like it's a couple of millimeters big, and we've used a trick here, and that's to do with this rig there. So what we do is we shine white light in at a really high angle, and it scatters off the surface. So you get to see all the lumps and the bumps. So rather than seeing the actual nanoparticle itself, which is way, 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 way too small to actually see with this rig, what you see instead is all the light which kind of hits it and gets scattered in a random direction. And in that way, we get to see all of the nanoparticles there. Now, what I do with that is that I aim a laser at it, point, shoot, and get all of the signal back out.